Hello and welcome to TGI Kubernetes. This is, what are we on? Episode 24. I'm Joe Beda, I'm your host. In this web series, I don't know what you'd call this thing, but in this show, what I do is every week, Friday or so, I get together and with a bunch of folks who talk back to me on the chat channel here. How's it going, Josh? And talk about Kubernetes, go over what happened over the last week, and then pick a topic and go deep into it. Sometimes these topics are new projects where I play around with them sort of as a new user and we explore them together. Sometimes I'm going over sort of some of the fundamentals of Kubernetes. Sometimes talking about new things coming in Kubernetes itself. So it's always a lot of fun to do that. I did spend a couple of episodes actually doing some live programming. That was kind of fun also. So let's see. So I love it when folks talk back to me. So if you have any questions, if something's not clear, if you can't read what's on the screen, definitely let me know. I love to hear that stuff. So Lamati, welcome back. How's it going? And Josh there, Suresh, Keith is in Scotland, Tim in Chicago, Sean, Jim is in Florida, Carlos in Cuba. Good to see you. I think it's just totally crazy. Like when I was growing up, the whole idea of doing something like this with somebody in Cuba, just totally nuts. It's awesome. Q, Ale in Sweden, Elric, good to see you again, man. Ors, Justin, Vancouver, just to the north of me here in Seattle, and Jason, good to see y'all. All right, so today's topic is we're going to be talking about the jobs object, which is a way of doing run to completion tasks versus daemon tasks, things that you want to keep up and running all the time. So we're going to dig into that, but I do want to spend a few minutes up front talking about sort of what's been going on this week in the Kubernetes world. There's, nothing has happened this week, really. I mean, okay, maybe some stuff has happened. I'll talk about some of the stuff that's happened, and then I'll try and make my way through a bunch of stuff that I have sort of sketched out in my brain about the jobs object. I'm feeling a little underprepared this time. I've been so busy this week, but I think it'll turn out good regardless. So I think we're going to be in good shape. So Dan and Aaron, good to see you. All right, so Lemanis, what do you think about CoreOS getting bought? What, that happened? I didn't hear about that. No, we're going to talk about that. Vinette in India, David, good to see y'all. All right, so let me go through, and I'm going to try and keep this down to not too over an hour. They've been getting longer and longer, and I know that there's a limited attention span for folks to actually watch this stuff. I know you all are committed, but I don't think you need to be 2 hours committed to learn something, so let's see if we can do better with that. So let me switch to my screen here, and obviously the big news this week is the CoreOS folks getting purchased by Red Hat. Really exciting stuff going on there. I think it's good to see that Red Hat's doubling down on their investment in Kubernetes. Obviously, they've been partners in the community for a long time, and so really, really cool to see that happen. And I think a lot of people have a lot of questions around this. I think, and I think, there's still some of those questions are being answered over time. I'll tell you sort of what I've heard and what I've heard about here. So the first thing is the purchase price was $250 million. As somebody with a startup, the fact that, when you read these things, if they talk about the purchase price, then it's a good thing. If they don't mention the purchase price, then there's a reason why they don't mention it. I think this is a good exit for CoreOS. I'm sure, starting a company, you always have dreams of IPOs and billions of dollars, but this is a really good landing for everybody, and I'm really, really happy for everybody at CoreOS to see that happen. So that's really good. So David is in the GKE SRE office in Seattle. Oh, good. And you're on call. I'm sorry. All right, so here's a little story about Google on call. If you use something like Prometheus, there's this alert manager thing, and it can deliver emails or calls or whatever. Google has its own system for doing all that stuff, and it'll actually call you up when you get a page. And one of the things when you're on call is you'll have a lot of alerts, and when something starts failing, everything starts failing. And so there is a button that you can press on the Google On Call app or when it calls you that says STFU, which you can look up what that means, because I'm not going to swear in this fine family-friendly show. But if you're on call and it's totally coming at you from all sides, you can tell your phone to shut up. And nothing feels better than hitting the STFU button when you're actually on call and getting slammed. So that's a lot of fun. All right, so back to CoreOS. So good purchase price. Really happy to see those folks land well. There's still a lot of open questions, and I think some of those are getting answered. So the first one here, and this is an email here. I'll make it a little bit larger. That was sent to the CoreOS user Google group, and somebody pointed this out to me. And this calls attention, and so I think this is one of the questions that's been on everybody's mind. What's going to happen to CoreOS Container Linux with the fact that like Red Hat is a Linux company, and they have RHEL, and they have Atomic, and they have everything else, and Fedora going on. What is going to happen there? And there was some confusion. There were some questions there. I think this goes to answering some of it. I don't think it answers sort of the total long-term view of it. But I think what it says is that, like, I don't believe, if I'm reading this right, and you can read it yourself, I don't believe Red Hat's going to be offering commercial support for CoreOS Container Linux. But that doesn't mean that Container Linux is going away. I think this line here is really interesting. Red Hat plans to continue Container Linux development. So that's, I think, for a lot of folks who've bet on that, who are using that right now, I think that definitely helps them sleep a little bit better. It at least says that this isn't going to disappear overnight. They're not going to yank the rug out from folks. And I wouldn't expect them to. I think both Red Hat and CoreOS, they understand that they have a commitment to users, and they're not going to leave people hanging like that. But it's good to actually see that written down someplace. So David's saying, I'm especially looking forward to Tectonic possibly getting open sourced. Another entry in the fact suggests this will happen, but no definite commitment. Yeah, I think the other question is what's going to happen with Tectonic. Even looking at something like Quay, generally Red Hat open sources a lot of stuff. Are some of the Quay server-side components actually going to get open sourced also? So those are some questions that I think folks definitely have. It's also really good to see a company with means. I think one of the things that gets lost in all of this is the fact that CoreOS is the company behind etcd. There's other folks obviously involved. etcd is a core dependency of Kubernetes. It's really good to see a company like Red Hat, standing behind etcd as it continues to mature over time. So that's really, really good. I was wondering if they're going to kill Tectonic or not because of OpenShift. I think that's, honestly, that's one of the questions that folks are wondering is Red Hat's current strategy with OpenShift is they ran ahead, added a bunch of features to what's kind of a fork of Kubernetes with OpenShift. They're working now to take all those features and upstream them. That's a painful process just because, people are taking a close look as these things make their way upstream. RBAC is a good example of something that was upstream from OpenShift. Meanwhile, Tectonic is relatively close to upstream Kubernetes. It's the same Kubernetes. I don't believe Tectonic actually carries any patches long term for Kubernetes, and so that's sort of pure Kubernetes-ish type of thing that Tectonic is versus the OpenShift, which is kind of a fork of Kubernetes with extra features. It's not clear yet how they're going to reconcile those two. So the one thing to keep in mind here is that there's this FAQ here that's linked off of this, and I'll include all these in the show notes, that has a lot of questions and answers. And so this, isn't going to give you sort of certainty on everything, but I think this definitely gives some certainty there. But related to CoreOS, there's two, it's a great crew there, super friendly with a lot of the folks there. So the first one is Brandon Phillips, is the CTO of CoreOS, and he had a daughter. He and his wife had a daughter on January 10th, I believe, is when she was born. So there's the picture there. So congratulations to Brandon. Really cute picture. And I know he's not getting a lot of sleep. He's been working when he can, calling to some of the steering committee meetings and stuff like that. So congratulations. And he says that it's been a really, really interesting January for him. So between the selling his one baby and then having another, right? That's definitely an interesting month for him. So do I think that Brandon will stick around? I have no idea. I don't know how these things work out. All I know is I love working with Brandon, and I'm sure whatever happens with him, he'll be doing some really interesting stuff. And then there's Brian Redbeard. Okay, so you guys know. So like I'll click on his picture here, and there's like. So this is Brian Redbeard, okay? he has or had this amazing beard that he cut off. And I believe at one point he made the commitment that if CoreOS IPO'd, he'd cut off his beard. But he figured this was close enough, and he cut off his beard. So anybody who's known him, like that's a pretty big change. So that's hilarious. So congratulations. Yeah, Brian No Beard now, right? He's gonna have to change his Twitter handle. So congratulations to the CoreOS folks. That's super, super exciting. Good for them. So the next thing I want to talk about is here at Heptio, where we started talking about some of the stuff that actually we've been doing for a while, but we've been working on how are we describing it, how are we selling this to customers, and so we announced this thing that we're calling the Heptio Kubernetes subscription. I gave it the name the Undistribution or the Undistro. The idea here is that a lot of times people want, and let's see if I can find the. So here's sort of like the summary here. A lot of times they want a distro, but they don't want a distro. They want somebody to have their back. They want somebody who will, cut them new binaries with a hot fix if they need to. They want somebody to call, and they want advice on sort of how to put everything together. But they don't want to get locked in long term to, saying, hey, I'm going to have to go through and repave the world to get off of this offering. They don't want to feel that level of lock-in. And so that's how we're viewing our offering here around HKS is we want to give people a lot of the good stuff about a distro, but also as much as possible, keep them upstream, aggressively keep them upstream so that they have choices and they don't feel like they're totally locked in. And also so they can take advantage of the larger ecosystem that's going out there. So that was really exciting for us. You might have seen some news on that. Let's see, other stuff that we have going on. If you're coming to KubeCon EU, the day before that is the Contributor Summit. The folks in Contribex and the community managers, and I think this is mainly being driven by Paris, who's at Google, and George, who's at Heptio here, are putting together a Contributor Summit. And one of the things that we're working on here is to keep this moving and really view it as a way to sort of cross-pollinate information. And the other interesting thing is that there's a new contributors track there also. So if you want to get involved in Kubernetes, and if you're going to be at KubeCon EU, and you want to become a contributor, we don't want that Contributor Summit just to be for folks who are knee-deep in Kubernetes, but also folks who are interested in perhaps getting knee-deep in Kubernetes. So this is exciting. And last time we did this, it was good, but we didn't get the word out soon enough. And so it's great to see Paris and George starting to figure out the details here and see this start to shape up now. So that's been announced also. Let's see, other interesting stuff is that there was a redo of some of the Kubernetes documentation on the site, which I think is really, really interesting. It's using this, the idea of personas is like I'm a developer or operator and sort of what level am I looking for and then sort of what tasks do I want to do. So I'm a cluster operator and I'm intermediate, so I'm interested in security best practices, for example. And here's some resources here. And this will be expanded over time, but the idea being that instead of having a big pile of documentation, we have a flow that really works with who you are and what are you looking to get done that gets you to the right part of the documentation. So that's really exciting. I know that the SIG Docs folks have been working on that for quite a while, so it's exciting to see that stuff get out there. And then the final thing, because I'm totally taking too long here, is this is a challenge to me. One of the things that we've been talking about is like whenever we talk about Kubernetes, a lot of times we'll say the master and nodes, right? And the terminology with master is brings to mind the whole idea around master and slave, right? And so that's obviously super distasteful and offensive to some people. And so we're, and beyond that, the name master, there really is no master in Kubernetes. There's times when you're running Kubernetes where you actually put a lot of the control plane on one single machine. And so I think colloquially we refer to that as the sort of the master machine. And sometimes we'll refer to the control plane in general as the master, but it's really not a super accurate description of what's going on. And so both in terms of like, hey, let's just try and sort of not bring up these bad connotations that can be offensive or bring to mind some really unfortunate things. along with let's use probably more meaningful technical terminology, we're going to try and actually not use the term master as we work through as we talk about stuff. So if you find me using the word master on TGIK, please call me out on it, and I'll slap myself here, because I think big part of this is we're going to be changing the documentation. It doesn't show up in the code too many places. I think kubadmin will probably be the most impacted. And so, but I think the big thing is just changing our vocabulary, changing how we talk about it, and retraining ourselves to actually think about this in more exact terms. So Q says, I like the intention behind it, but with so many different terms and the changing, it just makes it harder to keep up. I think that is a concern. I totally hear you here. We are, one of the things here, and I think, there's a lot of people coming up with ideas on sort of like what are different names we can use here. I think one of my criteria here is I just don't want it to be too cutesy. I think like we already have enough sort of specialized cutesy terminology in Kubernetes. Like everybody's like, what the hell's a pod, right? I don't think we want to introduce another one. So I think somebody's like, talking, but I think like control plane is relatively well understood. So that's kind of where I'm thinking right now. But I still think we want to give folks a chance to sort of weigh in and for people to sort of wrap their head around this. Okay, so that's sort of announcements of what's going on in Kubernetes this week. If y'all have other questions about stuff, feel free to drop it in the chat logs, and I'll see if I can go ahead and get to it. But I'm going to try and keep moving with stuff. Just because, again, I'm really bad about this, and then these things like last for 2 hours, and nobody needs that. So yeah. Cutesy names. Yeah, I appreciate that, guys. I appreciate folks, the suggestions there. All right, so I have a cluster up and running, and what I'm going to mostly be doing, the outline of what I'm going to be doing is going through. So there's Kubernetes up and running here. So this is the book that Kelsey, Brendan, and I wrote. I wrote the jobs chapter in here. This is chapter 10. Let's see if this thing focuses. Maybe, yeah, the jobs chapter. And so I'm going to be using this as an outline to actually go through this stuff. But along the way, hopefully I can give some more color and you'll actually see it in action. I think that'll be kind of fun. But if you want to play along at home, you can go ahead, and if you have a copy of the book, you can get that out. What I wanted to do is say, hey, you can go download a free copy of the ebook here because we sponsored an excerpt of the thing. And so and we actually have printed versions of these that we actually give out, when we're at conferences and stuff. But this was limited to 100 pages. And I had to choose which chapters were in and which chapters were out. And when I did it, I think I chose not to include the jobs chapter. So I wanted to say you can actually go ahead and get the excerpt for free, and there you go. But it turns out that the excerpt doesn't have the chapter that we're covering. But if you're looking for other sort of, reference material, you can go ahead and download this. So I had this all prepped, and then I went and grabbed a copy. I'm like, darn, we forgot to, we didn't include that chapter. It was tough to choose what to include and what not to include in the excerpt. All right, so let's see. I'm going to reorder some tabs here because I'm going to get to, so there's that. Sorry, I had some extra tabs. So here's the documentation on the site on the jobs thing, and I think this is pretty good, but I don't think let's sort of dig into it a little bit. So this is good reference there, but what I'm going to be talking about is the different types of scenarios of where you'd be using jobs, and so the first thing is what do we mean when we say a job versus regular usages of Kubernetes? And it's actually a pretty simple and yet subtle thing, is that regular Kubernetes, if something fails, you want to restart it. So the goal of most sort of and it's kind of a daemon mode. So sometimes people talk about daemons versus jobs or daemons versus batch. But the idea is that the goal is to keep something up no matter what. Right, and so that's most of the usage of Kubernetes. If you do a deployment or stateful sets or a lot of the other usages of Kubernetes, it's really keep this thing up no matter what. By hook or crook, try and keep this thing running. Jobs are different. Jobs are run this thing until it exits. And there's different ways to actually sort of talk about exiting. And there's different, maybe you don't want to run one thing, you want to run 10 things. But it's really sort of run to completion versus run forever. And that's really the fundamental difference between when we say job versus when we talk about other things. Now, the interesting thing is that this still uses pods under the covers, right? So job is something like an init pod. So I think what you mean is a init container inside of a pod. And so the idea with a init container is it's something that you want to run to completion before you start the real task. So it's sort of a bookkeeping sort of preparation type of thing. And here, this run to completion stuff is really the main event. So it's the thing that you're trying to make work. And so I'll go through some of the scenarios here. And we're going to use QuarD as an example here. And when I built QuarD, I added some support to be able to do this stuff. And a lot of times, you can use this for like a one-off type of thing. You can use it to, where you have some predefined amount of work that you want to do. A lot of times you run it, but then it actually knows when it wants to exit cleanly. And so that's the idea behind jobs. And so there's 3 different scenarios that I'm going to be talking about, and these are the ones that are covered in the book. So the first one is a one-shot job, and this is like I want to run something, I want to run it to completion, right? You can set this up so that like if it fails, do you want to restart it until it succeeds, or if it fails, it's like boom, that's it. If the underlying infrastructure fails, it'll try and run it someplace else. And so there are some sort of quasi sort of like in distributed systems in general, this idea of like Suresh says the init container is paused, not finished. Okay, yeah, probably just so that if stuff is running, it's kept around there in terms of namespaces and resources that it's create. But I believe the main worker inside the init container actually is not running, even though the container is maybe paused. What was I saying? Okay, so the ideal thing here is that you'd want to, like, if you do a one-shot, you want to run once and only once. But it turns out that in distributed systems, doing something just once is actually really hard. When you look at systems like Kafka, they want to provide some sort of like guaranteed once delivery. But when components can actually crash, or you can have network partitions, you may say, hey, run this, and then and then you never hear anything back. Well, it may be that you didn't hear anything back because there was a network partition and the thing ran. Or maybe you didn't hear anything back because like the underlying machine crashed. And so there's sort of like, there's a Heisenberg uncertainty principle-ish type of thing going on here in distributed systems. So getting sort of a guaranteed run once, but only once type of thing ends up being very, very difficult. So even if you are using something like a job to do a one-shot type of thing, you still want to plan on the fact that like, hey, this thing may have already run before. And so as much as possible, build anything in distributed systems. The pattern here is to build stuff to be as idempotent as possible, which means that you can run it multiple times and you can get the same impact. And that really is sort of like one of the main sort of like design criteria for Kubernetes is we want to talk about what we want, not how to get there. So let's do a quick example of how this works. And so here I have a cluster. I got 3 nodes plus, and this is one of those places where we're going to have to work. This is a kubeadmin. It's based on an annotation here where we see master. So I can do kubectl get node. And when I look at this node, one of the things that you'll see here is this Kubernetes role master. And so we have a convention here in terms of roles. And then node role master. And so this stuff is built into kubeadmin, and then the kubelet knows how to actually call this stuff out and expose it. So that's something that we're going to have to work on. All right, so a little tangent there. Okay, so I have a cluster here with the control plane node, the infrastructure node. Should we call it that? I don't know. The control plane node plus 3 worker nodes. And what we're going to do, and I have a cheat sheet document here, is we're going to call this thing here. And so actually let's go back here and we'll look at what this thing does. So this is, I want to do a run. The -I says that I want to actually get the output stream to me. So the image that I want to run is this thing, restart on failure. So this is the thing that makes it a job versus not. And there's I'll go into a little bit of detail there because this is kubectl run is a little bit confusing here. And I want to dig into that. And then everything after the dash dash is our commands to the underlying image that we're running. And here we're running this with keygen enable, exit on complete, and then we want to generate 10 keys. So I'm creating private keys using a cryptographic algorithm. They take a couple seconds each to generate, and so it's a good sort of like short-lived worker type of thing for being able to generate stuff. So so the workload here that we're doing is generating a key. So this could be rendering a frame in a movie, or it could be resizing an image, or it could be encoding a video, or it could be, I don't know. So there are any number of sort of work queue items you could think about doing there. So let's go ahead and run this and see what happens. And what I'm going to do is down here, I'm going to do kubectl get pods -w. So we'll actually see this thing running. The -w means a watch, and so as things come and go, we'll actually see them come and go here. Or actually, no, let's do this instead. We're going to do get pods. We're going to do watch. Every half a second, we're going to call kubectl get pods, and we're going to output that to the screen. And so we just got no resources found. And now if I go through and, oh, it's my paste buffer there. I'm going to go ahead and run this. And here you can see container creating, so it's downloading stuff. Now it's running, and I think the -i should actually stream stuff out to us. There we go. And it's done. And every time it generates one of these things, it's dumping a SHA-256 of the private key that it actually made, or the public key. I don't know. So you can look at the QuarD code if you want to see how this stuff is working. And so you can see this takes a couple seconds each to run. And then when this runs, it's going to exit with success. And then the whole thing is going to actually shut down, and the pod will no longer be running. I should have done 5 instead of 10. This is taking longer than I thought. Okay, we're going to scale this down a little bit to see how things work. So any questions so far as I'm going through this stuff? No? All right, we're going to watch this go. So yeah, so I added a bunch of the features to QuarD as I was developing this chapter, just so that we had something that we could poke and prod and see how things work. Okay, the use cases for something like this is when you just want to like run something and then have it exit. And so sometimes like people might use this to say do a database migration. Might be something that you'd want to do, or if you have sort of a one-off task of something that you need to do. So like you could do this of like, hey, I want to copy, okay, so let's say that you want to copy some data from, Google Cloud Storage to S3, right? And so you have a command line tool to go ahead and do that. You could, on your Kubernetes cluster, you could run a one-shot thing that actually goes through and like copies the data from one to the other. You're running that in the cloud. Once it's done, you're done. But after that, you want to be done. So in some ways, like we were looking at the workflow systems before. This is like a super duper simple sort of single stage for the workflow, right? So this is this ends up being something smaller than the workflow system. So David says, do jobs have any facilities to help job writers parallelize their job, e.g. metadata like you are shard 5 of 150? No, there is no assignment there, and I think this is something that in general Kubernetes has avoided for a variety of reasons. I think one way to think about doing this is it's not uncommon, to have a bunch of things join, communicate with each other and sort of do like a ring hash so that they can actually figure out which part of a hash space that they might actually deal with. Yeah, I'm trying to think. There's other techniques that you can use there. The reason why I think people are a little bit allergic to sort of assigning like shard numbers to individual, tasks when we're doing parallelism, we'll get to the parallelism side of the house, is because and it doesn't apply as much to the job stuff as it applies to the long running tasks. Is that when you have long running tasks and you have to shrink them or increase them, if you actually give them indexes, and this is the way that Borg and something like Marathon works, then when you shrink, you have to always shrink from the end. So that's very deterministic which things you actually need to remove, which gives the system less flexibility around that stuff. And then also with respect to upgrades, you have to be if you're doing a rolling update, you have to be very, very disciplined about sort of how you do that. And what you end up doing is building that rolling update state machine into the core of the system. Whereas right now, replica sets and pods themselves have no idea about how deployment does a rolling update. And keeping those separation of concerns is enabled because we don't have any guarantees around indexes. Let's see. I can't think of anything I want to do that I don't want to do again after a period of time. Might just be limits of my imagination. Well, yeah, I mean, and then Lamati says, or no, Q says that, Q says, okay, this isn't something you'd use in Helm. Yeah, Helm doesn't do workflowy types of stuff, so I don't think it does. So I don't think this would be totally appropriate in Helm. And then Sean says you can do cron jobs for sort of repeatable things. So yeah, so cron jobs are definitely the way to do. And another thing to think about is that, like, if you need to sort of like, if you're writing a program and that program says, hey, I need more work, I need to do a lot of stuff. Like traditionally you think about like, hey, I'm gonna like introduce some threads and then I can use multi-threaded, right? But you can only do multi-threaded up to the number of CPUs on your machine before you get diminishing returns. If you do it right, you can launch a bunch of jobs and then those jobs actually essentially become sort of a multi-processing. So now you're thinking about extending your stuff across the cluster instead of extending it just across the machine. Oh, Helm does have hooks that let you run a job. Okay, so I'm wrong. Bismarck is calling me out there. I'm wrong. Okay. Yeah, and then it says, at this point, can you run the job again, or you need to clean up the completed job? So if I do kubectl get jobs, what I see there is that it's done and it's successful. If I do kubectl get pods, I get nothing, but if I do -A, I actually see I get this thing, and I can actually then go ahead and I can actually get the logs for that thing. And so you're right that there's stuff that's left over here after I go ahead and do this stuff. So now I can go through and I can do delete jobs one shot. And that'll go ahead and clean this stuff up after the fact. Now, if you want, so Jim says, I use jobs to launch database conversions and seed scripts from CI/CD concurrently with the Canary deploy. Yeah, so that's a great example. So if we do kubectl, now I don't know. Sorry, I'm looking at what's going on here. Give me a second. Port, quiet, blah, 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 blah. Okay, so it's hard to get this with kubectl run, but we talked about this in a previous TGIK. So let's go ahead and we'll switch to the YAML equivalent of this. So the API version is batch, it's job, it's one shop. Again, this is directly out of the book here where we're doing some metadata and labels and stuff like that. Restart policy on failure. But one of the things that I can do here is, and I think, oh man, now I'm like going to try and remember this on the fly. I'm going to look at the API. So what happens if I run the job again before deleting the results? I believe I would get an error if I tried to run the thing again because it's going to try and do a create. If you do an apply and the thing's already committed, I don't think it does like a reset back to sort of like the unrun state. So at that point, it's done. So let me pull up the API reference. But one of the things, and this works really well with jobs, is that, and we talked about this in a previous episode, is that you can give a prefix and then have Kubernetes actually decide to what name that thing is going to get. So you can either name your objects or you can have Kubernetes decide the name of the object. Why is this thing not? Come on, man. Is this part of the site down? This stuff is all hosted on Netlify, so it should just work. Let's see if that loads. Extensions, this is the wrong API group, but I'll look at it. Sorry, I'm looking this up because I can't remember the name off the the top of my head, so I'm digging deep here. We need better API documentation, better sort of like YAML descriptions in general here. So generate name, that's the name of the thing. And so here's this is the sort of the canonical place where this stuff is, but this flows into the other documentation around the API. So if we do, instead of name here, we do generate name. So let's do that, and we're going to change this thing to like 2 instead. Do kubectl apply 1-f. What is it? It's called job one shot. Oh, resource name. What? It should be able, oh, maybe it's job different? What the heck? The name should be made unique by the server. The name will be made unique, and the name return client will be different than pass. The values field will be combined with the unique suffix in the server, blah, blah, blah. If this field is specified and name is not present, server will not return a 4 or 9. Instead, it will return 2 when created or 5 when server timeout. So why isn't this working? Is it, what the heck? That should work. Do I have to quote it or something? I'm confused. Okay, job one shot created. So generate name didn't work. Why didn't it work? Capital G, maybe. Generally, like it's camel case like that. I don't know. Job generate name. Oh man, did I stumble on a bug? Boom, boom. Oh, it's kubectl apply doesn't work with that. Okay. So it was because I did apply. I can do create, and there, boom. Okay, so yeah, so this, sorry about that. Looks like we tried to use jobs for cron jobs on November 7. They were error prone, so we went back to deployments. Okay, yeah, I'd like to dig into that queue, but without going into more detail. But I just wanted to call out that that generate name plus jobs ends up being a powerful combination, right? Because now what you can do is you don't have to worry about creating unique names. You can keep your old versions along as you go. And so you might want to do something like with the prefixes, maybe the time or the date that you ran this stuff, and then you can maybe have some script that helps to GC these things after a certain amount of time. So now we have these 2 jobs. One of them's finished, the other one's running. Kubectl get. And so you can see, and then it actually there's when it completed, how many completions, what happened there. Get pods. If I look at all the pods, you can see here's, and prefix is predictable, so you can try and figure stuff out. But you can also go through and use labels to actually relate these things back and forth too. And then we can go through and we can kubectl logs, and you can see there's the logs, and we ran 2 of these things, so we're good to go. So kubectl get jobs. Let's go ahead and delete these things. Oh, it was on shot, not one. Oh, I screwed up. Oh well. There you go. Okay. All right, so let's go back here. So here's the equivalent YAML for this thing. Hopefully there's no surprises there. Now, one of the things that we can do here is let's simulate a failure, right? So let's go through and we'll do it's keygen exit code 1. So now when this exits, it's going to exit with a 1 instead of a 0. So those who are not super familiar with sort of Unixy stuff, when a process exits, it actually returns an exit code back to the calling process or your shell or whatever. And unintuitively, 0 means success, and any other number actually means failure of some sort. There's also, like, if it's killed by a signal, it's a negative number. If it's a positive number, and there's conventions, and sometimes people document this. But for the purposes of Kubernetes, it's really sort of like 0 success, anything else is failure. So now we're going to have this thing exit with 1, which says that it's a failure, and we have the restart policy on failure here. And I'm going to change this back to just plain old name because that'll save me some typing and copy and pasting. And let's do a create on this stuff. And, and then we'll go through. And this thing's still running. We can see it's running. If I do the -F, I think that does a follow. So that's essentially saying read the logs and then stream any logs afterwards. So we can actually see that this thing's starting up. We're going to generate 2 of these keys. And then it's going to exit. But it exits with an error. And then the job controller is going to go ahead and if all goes as planned, it should actually go ahead and restart the thing. So restarts 1. Oh, now it's in, okay, so it waits a little bit just so that it doesn't. And so what we can see here is that when it exits, it doesn't kill that pod. It goes ahead and it restarts the pod on another, it restarts the pod in place, right? The container in place when things exit. So that's what we're going ahead and seeing there. And so this thing will just keep going forever because we set the program to always exit with an error and we also set it to always restart when we get an error. So we can go ahead and if we look at this, you can see, let's see, there might be in the, this is the job. Does it actually have status, active, start time? It doesn't have a list of sort of like, you know, from the job's point of view, it's not paying attention to the pod. But if I go ahead and I look at this, what you'll see is you'll see the state here will show it. And then if I do, instead of get, if I do describe, this also goes through and reads the events, and you'll actually see some of the history of what's happening. And so to keep the event stream from getting sort of totally overwhelmed, a lot of times these things will be collapsed, and you'll see, hey, this happened 4 times over the last 2 minutes. All right, so we'll go ahead and delete the job, and that should go ahead and kill the pod. And there we go. Actually, let's change this thing so that we're looking at jobs and pods. And then we're also going to give it the -A. So there we go. So it's terminating. Wait, does not? Okay, yeah, because the. So there we go. Okay, so that's how things work on failure. Oh, I was going to talk about kubectl run. So kubectl run, I think, tries to be easy, but in return has some hidden complexity that can be confusing. And so let's look at the documentation. This is the. Why is this the 1.4 documentation? That's strange. Oh, that's not the thing that I want either. Gar. All right, well, we'll look at this even though it's strange. This is the old stuff. So, oh man, that's not the... All right, maybe, oh, here we go. Okay, so there's a chart here, if I can find it, that talks about this. So this is not helpful either. Man, things keep moving on me. No, there's that. Here, this is what's so confusing. This chart is beautiful. Okay, so essentially what this is saying is there's a whole bunch of options to kubectl run, and the type of object that it creates under the covers really depends on the options that it sets. And it also depends on the cluster that you're running too. So I think this is like some hidden complexity. I think this is trying to hide some of how Kubernetes works to users, but in reality, it means that you have to sort of have this chart decode what the thing's really doing. So the default is that you have this like restart equals always, and that creates a deployment. So most of the time when you do kubectl run, you'll get the restart equals always, and then you're up and running. So Pat says, so do we always have to have our own job cleanup process, no inbuilt GC after a certain amount of time for completed jobs? I'm not sure. I don't think so. That's not a feature that I've seen yet. It may be that somebody has built some sort of TTL. There's Kubernetes garbage collection, container collection user. No, this is all at the node level. Yeah, I don't think anybody has built that out. And this is the type of thing that that is somewhat, I wouldn't say trivial, but totally doable from the outside. So you could imagine that you could have, let's see, so there's, if jobs had something like a cron job, failed job. Well, the cron job, you have the overall cron job, and then you have all the runs of the cron job. But each job itself is kind of like a one-shotty type of thing, right? So the idea is that, like, if you have your own process that's, say, triggering jobs based on some sort of, like, Jenkins thing or whatever, you want to say, hey, if this thing's older than a day, then go ahead and delete that. And so I think it's totally, like, yeah. And so Pat's like, you can do something in a cron job. What I would do is have something like a label or an annotation that says, hey, after a day, clean this thing up with maybe a default process for something that's not there. And then you can do a query and just delete those things. And so do that sort of, maybe on your own cron job, or have a controller that keeps track of that stuff. I don't think anybody's built that in yet, though, to be honest. So container v1 core, so this is... So let's see, it would probably be deletion. This is all, so stuff like the deletion grace, that's for graceful deletion when it takes time for things to actually be deleted, especially namespaces. Yeah, so it's nothing that's sort of a generic built-in thing, because it would probably show up, I'm guessing, here in the metadata thing, because this is where you see things like your owner references and stuff like that. So yeah, that'd be a fun little add-on for somebody to write there. That'd be pretty cool. Okay, so kubectl, so it's interesting. If you do restart on failure, then it becomes a job. If you do restart equals never, then it creates a pod for you, a plain old pod. Or if you pass in the schedule thing, then it'll go through and actually create a cron job for you. And so the fact that kubectl run is kind of modal like that can be a little bit confusing for folks. If you want to be super specific, you can pass the generator flag, and the generator flag lets you specify exactly sort of what template you want to do for kubectl run. Okay. Let's see. What do we want to do? So that's pod failure. All right. So now let's talk about parallelism. So there's two properties on the job. And if we pull up this here, there's one called parallelism and there's one called completion. And what this says here is it says that I want to run 10 copies of this, 10 instances of this thing to completion. That's what completions is. And I want to have at most 5 running at any one time. So restart on failure gives you a job. That seems like a really weird wording for it. I get it now, but it's no way clear to me. Yeah, I think that kubectl run semantic is super unclear to folks. I think most people just use it for deployments and don't really look that much deeper for it. Yeah, but I think it's a great example of by trying to make things simpler, you kind of introduce complexity, and so you're kind of moving the complexity around, right? Instead of making people recognize that complexity initially, you're just sort of punting it down the road a little bit, which sometimes can be good. But in doing so, you're actually creating sort of some complexity debt for users, because now not only do they have to understand the core concepts that they didn't have to understand when they called kubectl run to begin with, but they have to understand sort of the wacky behavior of kubectl run. Okay, so here we're saying that we want to run 5 of these at once, and we want to run 10 of them until they go to completion. I'm going to detune this down to 2 so it moves faster. So I'm going to go ahead and run this, and what we're going to expect to see is 5 jobs running, and then over time we're going to see those replace each other as they actually get replaced. But we'll never see more than 5 running at a time, and we'll have seen 10 run total. So let's go ahead and do that. And so this is just like what we had before, except we changed the parallelism and the completion. Those things default to 1. And so if you don't set these, the behavior that we got before was as if those things were each set to 1. So kubectl create -f jobs parallel. Is that what did I call it? Parallel, yeah. All right, so we see 5 of these things creating. A couple of them are running right away because probably those landed on nodes that had already downloaded the image. Now they're all running. I can pick one of these things and do kubectl log. Oh gosh, if I do kale, that should tail all of them. That's a cool utility called kale. Okay, so we saw 1 exiting, and then we see some new stuff starting. We can see we had 1 successful, and this should update. So now we have 3 successful. And when they're in this completed sort of cleaning up state, that's enough to actually say, hey, let's start the new ones off and running. Oh, and since I give the -a, it's including the completed ones, right? And so now we have the next 5 running, or next 4 running. 1, 2, 3, 4, and we've completed 1, 2, 3, 4. So it's actually, the job is catching up with stuff. Yeah, so kale is really cool. There's a couple of sort of like, you know, tailing things that let you tail a group of things. Kale is the one that I've been using recently. So it's a really fun project. All right. I'd love to get to the world where these things can be more integrated with kubectl, or people feel comfortable adding this stuff to kubectl. But right now, the mechanics of actually getting stuff into kubectl is a little bit harder than I think anybody would like it to be. So we have 1 that we're waiting for here. Boom, it's done. Now the whole thing is done, and those things are all completed. And so you can imagine that if you if you just want to do some work and you want to, say, generate some stuff, you can go ahead and do that. The fact that you can't pre-parameterize these things, the fact that you can't do something along the lines of, like, you know, say, hey, give it the index of which number it is in terms of things running, definitely, I think, limits the usefulness to some degree of this scenario that we're running with here. Let me see if, and I don't think anybody, so that might be, I could see relaxing that rules of actually giving an identifier with respect to jobs, because I don't think some of the same concerns that we had before. But if something fails hard, right, you want to replace it, you replace it with the same index, so now you may have 2 things running with the same index. People don't expect that stuff to actually to happen. So yeah, Dave, yeah, this is saying the same thing I did, where naive task numbers would actually. So parallelism plus completion is a good illustration of where naive task numbers would fall down if not all the pods are running at once. Yeah, exactly. Right, so do you want, like, here's your run number, or here's your instance, number? That's the type of thing that falls down. So that's really interesting there. So let me see. Give me a second here. Now, one of the things. Okay, so yeah. Now I want to keep moving here. So the next thing we're going to do here is we're going to go, this is probably the most complicated example, is we're going to do a producer-consumer queue. And so I had an image in the book that I drew out. Let me see if I can hold that up here. Let's see, does that work? It's very simple. We're going to actually build a little, like, in-memory worker queue, and then we're going to bring up a bunch of tasks that go ahead and pull from that worker queue. And when the queue is empty, everything's going to shut itself down. Q says, I wish I could give a portion of a name in kubectl. It's so annoying copying and pasting everywhere. Yeah, for sure. Especially with the port forward, and we're going to get to that pretty quickly here. So the first thing that we're going to do here, and I don't know why I did this as a replica set before, but in the book, but let's. So if I look here, what we have is we're going to run a replica set. This could very easily be a deployment also, where we're going to run quard, and it's going to do nothing special. And we're going to call this thing, this is going to be called our it's going to be called Q, is going to be the name of this thing. So let's go ahead and start this guy up. Let's clean up our job here. Kubectl kill, kubectl delete job parallel. And boom, we should see this all disappear. That's exactly what we expected. Kubectl create -f the queue. Okay. So that's up and running. just as a plain Jane version of QuarD, because this stuff is all enabled by default. Now the next thing we're going to do here is I have a command line here, and I'm going to run this, okay? And what this is doing is it's actually using kubectl to actually select this thing, and then and find the pod, and then we're going to do a port forward to that pod. And I'm going to run that in the background. And now if I go to my browser and if I do localhost 8080, you can see that here we are. We can see what's happening here. And so that'll spew stuff when it reconnects, so that's fine. So let's decode this a little bit just so that people know. So I'm getting get pods. There's a label selector here because I actually had, app equals work queue and component equals queue. So that's like if you have a bunch of pods running, that's a way that you can narrow it down. And then this thing is saying I want to pull out the name of the first thing. So .item0 metadata.name using JSON path. And so it's a little bit complicated, but the JSON path stuff is actually pretty powerful for being able to grab stuff out of the YAML when you're scripting stuff. I still would like to see port forward be able to be pointed at a whole service, or say like take a stable sort of single item out of a service, but I guess I have to write my own port forward or something I want to do at some point. And then I'm doing the port forward to that thing. So you may see people when they're doing similar stuff, they'll use proxy. Proxy's HTTP, and it'll actually try and rewrite some of the return content if it has a URL-ish type of thing in it, so that things work well when you're proxying UIs. So I generally use port forward when I can instead of proxy. So that thing's up and running. Okay, now the next thing we're going to do here is we're going to load this thing up with a bunch of work items. And so one of the things I can do, let's see, if I do, okay, and I'll show you, and this is just a simple, let's see, I have load queue. Okay. So I have a simple, there's got to be a bug for port forward to a group of pods already. There is. I think a lot of folks are assuming that you're going to do this stuff server side. My idea is just do it all client side, right? So if you're talking to a deployment that has 10 pods, open up 10 port forwards. And then when you connect, then you can actually, choose which one you want to talk to in a client side policy. And so then you could actually run the port forward in a mode where it's like, we'll always take the first one in a stable way alphabetically. And if that one dies, then take the next one in a stable way. So that way it's like, just pick one of them, but I want to talk to a consistent one, which is different from the way that services work inside of Kubernetes, where every time you talk to something, generally it'll pick a new one to talk to. A lot of times when you're using something like port forward from your desktop, you want to have that stability if you're running a group of things. But that's my side project that I have no time to work on. Okay, so here's what we're going to do here. So there's a simple RESTful API for this. We're going to use curl to do that. We're going to create a queue called keygen there, and you can feel free to look at the Go code for this stuff. It's all up there. And then I'm going to add 99 items here. Let's actually add 10. Oh, let's do 30. Oh, how did that happen? 30. Okay, we're going to do 30 items. And for each of those, I'm going to do a post to the queue endpoint that'll create a work item for that. So let's go ahead and do that. And you could imagine that you could dynamically do this. Bash. And then as it returns it actually returns a unique ID for that. So now if I go back to QuarD, and if we actually see the memqueue server, here's the documentation of that API, and you can see that we have 30 things in queued. Okay? And the reason we have 30 is because I went to 0 to 30 inclusive. That's just the way that bash works. This is a bashism there. So there we go. And so now what's going to happen is I'm going to bring up QuarD in a mode where I'm going to point it at one of these MQ servers, and then it's going to go through and it's going to go ahead and do a post dequeue, which grabs an item off the queue and then returns it, and then it's going to process that, generate something, and then if it actually, I believe, if it gets that 204 no content that says the queue's empty, then it's going to go ahead and shut itself down. So now let's bring up our worker pool, the consumer job, and let's look at what that looks like. So we have that job consumers here, and so here we're doing parallelism 5. but we're not actually saying we're not doing completions, right? So whatever, we're just going to run 5 until those 5 exit, okay? And then what we're doing is keygen enable exit on complete. So this is exit when you're done. But instead of telling it to generate an a priori number, we're going to actually point it at a specific memqueue server, and it's actually going to, and then the name of the queue that it's actually pulling from there. And then if this thing fails, it'll go ahead and restart. And so you can imagine you're writing code. You can have something that says, here's the work I need to do. You launch a bunch of workers. You have them do that work. You either explicitly shut down those workers if you're doing like a deployment type of thing, or maybe like, you want to have them shut themselves down, in which case the jobs actually make sense. Okay. If you want them to sort of exit gracefully when they're done processing stuff. Okay, so there we go. Now let's do kubectl create -f, and this thing's called job consumers. So now we have these things running. And let's go ahead and do kubectl logs. Uh-oh. Oh, you know what what did I do? I forgot to create the service. So yeah, so we can't talk to the thing because we haven't created a service. It's just a pod, or it's just a replica set running. So now we have to create a service for doing that. So right now, each of these things is retrying in a loop, trying to talk to the queue server, and it's like I can't talk to it. So this is another interesting pattern: is that when you start up a job, some sort of process, and it's trying to talk to something else, and it can't reach the thing that it's talking to, what should you do? Should you retry like this, or should you error out and exit? And there's really different schools of thought. I prefer to actually retry, because then when you're bringing up a whole bunch of things, the order ends up not mattering. So I forgot to bring up the service, and so from the point of view of these workers, that work queue server is not there, but what will happen now is as I bring up the service, all of a sudden these things will actually start talking to it, and the whole sort of system will click into place. But right now, the fact that this thing isn't making progress and there's no errors being explicitly thrown outside of the logs is something that you have to instrument for directly, right? So if I were building a real production system, I'd probably do something like point Prometheus at this, and I'd have it report errors when it's trying to dequeue, and then Prometheus would be tracking those errors, and then I would use that to figure out that something's wrong, versus doing something like having the thing exit out with a really noisy error. Okay, so kubectl create -f, and I believe so it's service queue. We're going to do that, and then we're going to look at the log, and then we'll give that a -f. And so it's going to retry, and now I think it started dequeuing stuff, maybe. If we go back here, we can see that the depth of the queue is actually, and the number of things dequeued is actually reducing over time. Okay, so these things, for whatever reason, they're not actually, when they actually do run an object, they're not, IO timeout, interesting. Okay, so the way that I'm actually doing this dequeue on this stuff, it's hitting this IO timeout. This one got in a weird state. Okay, now it's actually dequeuing stuff. So the whole thing kind of recovered after the service came back up. And you can see that these things are all dequeuing over time, and eventually this thing will empty, but everything will still be working. And we'll give that a few more seconds to go ahead and do that. And so you can go do the get stats here. That'll actually show you what the current stats are of the thing. So we can do curl HTTP localhost 8080, and then we're doing keygen stats. Oh wait, no, it's just stats. Oh, what am I doing wrong? Doing something wrong. What was my load queue? Localhost. I think it's memqueue. Is this all available on your GitHub to try and duplicate? Yeah, so all this stuff is in QuarD, and then the example, okay, so now, we see these things are moving to completed because they tried to dequeue, they got that error saying there's nothing left, and so they exited cleanly. And we have one that's left running, and boom, he's done, right? And so this is a really useful pattern if the size of your work items are different, right? If maybe one work item is going to take 10 minutes and the other one's going to take 10 seconds, well, this will kind of even out. You'll keep everything busy because they're each grabbing a work item as they go. And you'll see this, I mean, like you might not want to use the memory queue like this in a production system. You may want to use something that is a more formal sort of like, queuing procedure, queuing process, like something like Kafka might be more appropriate if you really can't drop an item. But it's not crazy to do something sort of, lightweight like this, depending on the application. All right, so that is the work queue stuff and the consumer job. So this stuff is all on, let's see, so if we go to, why is the emote, okay, weird. Okay, I do want to see, why is the stats thing actually not working? Oh, relative to server address memqueue server, okay. There we go. Those are the stats. And so that's the same stuff that we were seeing on the page. So we can go ahead and get that. Okay, so now if I go through, you were asking if this stuff is available online. If you just look for QuarD, here is the documentation for QuarD, including like all these command line flags that I have here in the memqueue server and stuff like that. Also in this org is examples, and Brennan put these things together. These are a bunch of the files here. This is all chapter 10, so a lot of the stuff that I was working through here are the files that we care about. So this is all companion stuff for the book. But I think between the TGIK and these examples, you should be able to make your way through it. Okay, so that's the core sort of like 3 different use cases for using jobs, like the one-shot thing. You want to do a parallel sort of like run to completion, or you want to like run things and then have them do some parallelism, but have them exit cleanly, and then have the job actually run to completion when those things exit. Now, there's one big gotcha here that I didn't include in the book and isn't fully resolved in terms of, it's kind of a missing use case with the jobs object, with the job object. And I want to call attention to Nadim here, who called this out to me on Twitter. And I hadn't, like, if I thought about this, I would have realized it, but I hadn't been aware of this issue. Funny enough, the person who filed the issue, which is I worked with Alex at Google. He helped work on Kubernetes and some other GCE stuff, GCP stuff earlier. But he's over at CockroachDB now. So he's the one who actually hit this one and filed the issue on that. And then Nadim, thanks for helping out. And then Jay Milliken here at Stripe, who I think is also an ex-Googler, suggested sort of a workaround for this issue. So the issue here, and I think it's obvious when you think about it, is that the pod only exits when all the containers in that pod exit. And so that means that if you're running a multi-container pod as part of a job, you have to have all the containers exit. But the use case here, the normal use case, is really one of a main thing that's going to run, plus some helper sidecars, where those sidecars might be doing some sort of like fancy, proxying, with something like Envoy, or to something like, say, Cloud SQL at Google. Those things might be doing logs collection, where you're actually running these things and they're uploading to the logs. And a lot of times those sidecars are not built to be able to exit cleanly based on some sort of signal from the running process. And so, ideally there'd be a way to coordinate these things. Like maybe like you share a file path and a volume, and when you drop a file in that volume, that's a signal to everybody else, hey, it's time to exit cleanly. So you could see that happening with, say, maybe a shared logs collector, right? And so that thing says, okay, I'm going to exit once I finish actually making sure that I upload all my logs to some long-term storage if it's like a logs collector. Whereas if it's some sort of proxy, and that proxy may want to do a clean shutdown also. But Right now, most sidecars are not built to exit cleanly. And so there's no way to say, hey, when this container ends, go ahead and kill this other container and then count the success or failure of the entire pod based on the main thing, not based on sort of, any errors across any of these things. So that's kind of a hole if you're using sidecars, and that's something that can be really annoying. So Jay Milliken here, I don't think I know him. This is obviously he works at Stripe. Let's see what, this is John. I don't think I know John. Do I know John? I don't think I know John. And so the suggested workaround here, and this is really kind of grotty, is that you sort of like create a container that has bash in it, and you use that such that when your main job terminates, you go ahead and touch a file, and then down here you have something that's going through and doing a loop to see if every 1 second to see if that file has been written down, and if so, it actually kills the main worker, right? And so that there's a way to sort of work around this and actually sort of retrofit that, but it's some sort of like nasty sort of bash jiggery pokery to use Tim's phrase. There's some proposals here in terms of how this might be solved. I don't know if anybody seriously is working on it now. But this is definitely some pain that some folks are feeling. So Dan says, I have the same problem. Wish it was easier to ask the kubelet to kill the pod for you. I have built-in cluster services to help do this. Yeah. So I think I don't know, honestly, I'm not sure which SIG this stuff rolls up to. My guess would be SIG apps. This might be part of the sort of workload APIs. But if you're going to be using this with some sort of sidecar, this is definitely something to be aware of. So I just wanted to call attention to that. All right, so that's all the stuff that I had planned. I'm definitely a lot shorter this week than I was last week, so I'm feeling good about that. I think I have a better idea of how much stuff I can fit into one of these episodes. Are there any other questions before I sign off about this stuff or about other stuff that's happening in Kubernetes? Because I'd love to be able to answer that while I'm here. So Parthenon said, missed it. All sidecars are just for the job kind. So this is really only most critical for jobs where you want to run a pod to completion. The pod only exits when all the containers in the pod exit. And there's no way to say, hey, this container is the primary thing. When it exits, kill all the other containers. If that was if that existed, then that would actually fit really well with pods. With the job object. So hopefully you guys all got something out of that. I'm not quite sure what I'm going to do next week for a topic. One of the things I do want to do is figure out, and I have to find some time to figure this out, is find ways to have guests on. And I'd like to do it. A lot of times when people have guests on stuff like this, they just have like somebody dial in with Skype or something, and it's just a talking head. I want to find a way where we can really have people share their desktops and actually do their own sort of demos and stuff like that. And as we do that, I think it'll be a lot easier for me to bring people in to really show their stuff off, go into some depth there. Definitely want to show off some of the other stuff that we've been working on here at Heptio. Things like Arc and Sonoboy have been on my list for a while too. So not sure what I'm going to do, but hopefully I can get the mechanics of doing that done soon. So Hangouts on Air is deprecated, and Hangouts on Air has huge latency, right? And so I believe Hangouts on Air is deprecated. So I'm still using YouTube for this stuff, and YouTube has sort of lower latency modes, but it's a little bit tricky. I do like Hangouts on Air though when it was well supported. So thank you everybody, and have a great week. If you sat through it this long, please go through and click the subscribe and give it a thumbs up and all that. I appreciate that. And I'll see you all next week. All right. Have a good one.